This video is on standard form, and it will help you understand what is meant by a number in standard form. So, what is standard form? It will explain to you how to convert numbers to and from standard form. It will enable you to multiply and divide numbers in standard form, and add and subtract numbers in standard form. Let's start off by having a look at what a standard form number is. They're also known, by the way, as scientific numbers. And they're called such because they're very useful for writing down large and small numbers. And in science, for example, if you're looking at biology or chemistry, you're looking at very, very small things, molecules, atoms, and therefore very, very small numbers are used in those type of experiments and things like that. And large numbers, astronomers and people dealing with very, very large numbers will also write numbers in standard form to explain very large distances and things like that. A number in standard form looks like either of the following two. So large numbers look like this. They look like a times 10 to the b. Okay, that's what large numbers look like that. And small numbers look very similar, a times 10 to the minus b. Okay, so a very small number will have a minus in the power. Okay, this is called the power, and this number comes before the times 10 to the power. So what does times 10 to the power mean? So let's have a look at that now. Well, 10 to the power means 10 times 10 times 10 times 10 times, keep going, and there are b lots of those, b of these, b of these, there are b lots of them. So for example, 10 to the power 2 means 10 times 10. There are two of them. Okay, 2 times 2 lots of 10. In other words, that 2 are the number of 10s that you would have. 10 cubed means 10 times 10 times 10. And, for example, 10 to the 6, that means 10 times 10 times 10 times 10 times 10 times 10. 6 of those. 1, 2, 3, 4, 5, 6. So it's 10 to the 6. But what about the negative numbers? What does 10 to the minus 2 mean? Well, it means 0.01. But why? Well, the reason is because 10 to the minus 2 means move the decimal point twice. 1, 2. So we can write and some more examples of some numbers in standard form. So for example, 2 times 10 to the 2. Well, remember that 10 to the 2 is actually 100. So this is the same as 2 times 100. Because remember, 10 squared, or 10 to the 2, is 10 times 10, and 10 times 10 is 100. So that's 200. 2 times 100 is 200. Or 3 times 10 to the 4 is 3 times, and 10 to the 4 is 1 with 4 noughts. So that would be, which is 10,000. So 3 times 10,000 is 30,000. But is there a better way of thinking about converting numbers from standard form to numbers like this? Well, the simplest way of doing it is just remembering that the power tells you how many times you move the decimal place. So here's an example. If we take 7 times 10 to the 6, it means we move the decimal place 6 times to the right. So move the decimal place 6 times to the right. But how do we move it to the right? Well, we can't unless we've got noughts there. So it starts off at 7 and it goes to the right 6 times. 1, 2, 3, 4, 5, 6. So it would be there. So the answer would be 7, 0, 0, 0, 0, 0, 0 point. And that means that this last 0 is not needed because it's after the decimal place. So that would be 7 million. 7, 0, 0, 0, 0, 0, 0. So that tells us how to convert numbers that are in standard form, that are representing large numbers, where this is positive, into normal numbers. So let's do some more examples of that. So here we're going to do some converting of large numbers to standard form. So we're going to start off with a large number. So let's do an example. Let's say we've got 6, 1, 2, 3, 4, 5, 6 noughts. Now that's 6 million. How do we convert that to standard form? Well, the rule is, if there's no decimal place, which there isn't, there's no decimal point in that number, then we add 1 to the end of the number. So let's do that. I'll do that in a different colour. There's our decimal place now. And we say that's equal to, and we need to think about it's something times 10 to the something. And we need to fill in these somethings here. Okay? So what goes inside there and what goes in here? Well, what goes inside the power is the number of times that you move the decimal point so that the number before the decimal point is between 1 and 9. So let's just write that down. This is really important. Make sure you move the decimal point so that the number before the decimal point is between 1 and 9. Between 1 and 9. So it starts off here, and we want the number before the decimal point between 1 and 9. We moved it once, and you say, is this number between 1 and 9? No, it's 60,000. It's nowhere near between 1 and 9. Move it again twice. 3 times, 4 times, 5 times, 6 times, and now we can see that the number before the decimal point would be a 6, and 6 is certainly between 1 and 9, so we stop. So how many times did we move that decimal point? We moved it once, twice, 3 times, 4, 5, 6. So we moved it 6 times, and that 6 goes in that box there. So that's the power, how many times you move the decimal point. The other number, this one here, is simply the number that you're left with here, before the decimal point, which is a 6. Let's do another example. Let's start off with 7 point, it's not point, 7, 0, 0, 0, 0, 0, 0, 0, 0, and we want to put that in standard form. Well, it's going to be a something times 10 to the something. There's no decimal point, so we put one right at the end here. And how many times do we need to move the decimal point? Once, twice, 3, 4, 5, 6, 7, 8. And now, if the decimal point is there, this number before the decimal point is between 1 and 9. We stop at that point. How many times did we jump? Let's have a look and remind ourselves. 1, 2, 3, 4, 5, 6, 7, 8. And therefore, the power is an 8. The number that goes here is just the number that's before the decimal point, which is a 7. So that means 700000000 is 7 times 10 to the 8. Let's do another example. Let's try and convert 3160000. Well, we know that the answer is going to be times 10 to the something. What's the something going to be? Well, put your decimal point in at the end because there isn't one, and let's move it as many times as we need. 1, 2, 3, 4, 5, 6, 7, and we stop at 7 because the number before the decimal point would be a 3. So we've moved it 7 times. We write the 7 as the power, and the number that we write here, now it's this time we've got to write 3.16. We mustn't forget all of these numbers, okay? It's only the ones that are the zeros that you can ignore there. So let's do another example. Let's write the number 149630000, and let's write that in standard form. Okay, well, let's try that. There's no decimal point, so we'll put one in. There it is. And remember the answers, times 10 to the something times 10 to the something. Let's work out the power first. How many times do we need to move the decimal point? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9, so we put the 9 as the power. What are we left with? The decimal points there, it would be 1.4963. Oops, that should say 63 there. 63. 1.4963. Okay, so that's quite straightforward. That's converting large numbers to standard form. Let's now look at converting small numbers to standard form. This is converting small numbers to standard form. So what do we mean by a small number? Well, small numbers look something like this. Let's do an example. 0.00001. It's a small number. It's fairly close to 0. 0.0001. Now we know that a standard form number looks something like something times 10 to the something. We need to work out what they are. Now this time we need to move the decimal point from here to the right so that the number before the decimal point is between 1 and 9. So let's just remind you that remember, move the decimal place so that the number to the left is between 1 and 9. That's what we need to do. But this time we need to move it to the right. And how many times do we need it to move the right by? Well, it's there at the moment. We need it to go 1, 2, 3, 4, 5. And then, once we've moved it to there 5 times, we see that the number to the left is between 1 and 9. So it's a 5 that goes up here, because we've moved it 5 times. And if the decimal point's now here, then we write this number in here. So that would be a 1. So that would be a 1 times 10 to the 5. But this is the important thing. When you're converting small numbers to standard form, you must remember that this is a minus. Small numbers have a minus number up here. So figure out whether you think there should be a minus number or a positive number up here. Small numbers have a negative number in the power. Let's do some more examples. So let's try and convert 0.00000 to 3 to standard form. Well, we know it's going to be something times 10 to the something. Question is, what are the somethings? Well, the power up here is gotten from the number of times you move the decimal point. So how many times are we going to move the decimal point so that the number to the left of the decimal point is between 1 and 9? Let's have a look. Well, it's here at the moment. 1, 2, 3, 4, 5, 6. And we stop there because the number to the left is between 1 and 9. So it's moved 6 times. So that would be a 6. But we started with a small number, so we must remember to put a minus. That's very important. And the number we're left at the start here is 2.3. So this number here must be between 1 and 9, and 2.3 certainly is between 1 and 9. Okay, let's do another example. Change the colour so you can see the difference. Let's try 0.0000264. So it's something times 10 to the something. And we know the something's going to be minus something because we're moving the decimal point. We've got a small number here, and therefore this must be a negative. How many times do we move the decimal point? Let's have a look. It's there at the moment. Ready? 1, 2, 3, 4, 5, 6, 7, 8. And stop, because the number now to the left is between 1 and 9, because it's a 2. So we moved it 8 times, so we write the 8 in there. And if the decimal point was here, between the 2 and the 6, the answer here would be 2.64. So there are examples showing you how to convert large and small numbers to standard form. And what we're going to look at next is, given a number that's already in standard form, how do we convert that to a normal number, whether it's a small number or a large number? Let's have a look at that now. So now we're going to start converting large numbers from standard form. In other words, they're already in standard form, and we want to write that standard form number into a normal large number. So here's an example. So we're given 2.1 times 10 to the 8. And we want to write that as a normal number. But it's going to be quite a large number because we need to move the decimal point 8 times. And in order to make this into a large number, and we know it's a large number because this is a positive number, in order to turn this into a large number, we need to move the decimal point to the right. So the number starts off with 2.1, and we need to move the decimal point to the right. So to do that, we need some zeros in there, don't we? And it starts off here at 2.1, so it starts off there, and we need to move it to the right 8 times. So it starts here 8 times. Ready? 1, 2, 3, 4, 5, 6, 7, 8. Let's just check that. 1, 2, 3, 4, 5, 6, 7, 8. So the decimal point now goes here. Oh, I can't quite get it into the right place. There we go, there. Okay, that's where the decimal point is now. So this is 2, 1, 0, 0, 0, 0, 0, 0, 0. Let's just check how many zeros we've got. 1, 2, 3, 4, 5, 6, 7. The one after the decimal point doesn't really count. 1, 2, 3, 4, 5, 6, 7, that's correct. So there we go, we've converted that large number, which is already in standard form, by moving the decimal point 8 times, but we need some zeros in there in order to move the decimal point. So let's do another example. Let's have a look at 613.25, which actually isn't a number in standard form, is it? Because this number before the decimal point is not really in standard, is not between 1 and 9, so it's not really in standard form. But anyway, if we're going to convert this into a normal number, then we need to move the decimal point how many times? Look at the power, 7 times. So we're going to need to move this 7 times from where it is to the right to make it into a bigger number. 1, 2, and then we need some noughts because otherwise we're going to run out of space. So okay, so let's see, it should be there. We need to move it 7 times. 1, 2, 3, 4, 5, 6, 7. So it goes here. So there's our decimal place now. New place of our decimal place. And remember the decimal point, the 0 after the decimal point doesn't really count. So this is 6, 1, 3, 2, 5, and then 1, 2, 3, 4, 5 noughts. 1, 2, 3, 4, 5. Okay, another example. Let's do 9.64 times 10 to the 3. Well, we know that we need to move, this is a big number, first of all, because this index is positive. There's no minus here, so it's a big number. And to make this into a bigger number, we need to move the decimal point this way again. So therefore, we get some zeros, enough zeros to move it, and we need to move it 3 times. So it would have been here, move it 3 times, 1, 2, 3. So the decimal point goes there. Again, if we put too many noughts, we might want to rewrite that as 9640. So that's us having converted a large number that's already in standard form into a normal number. And now we're going to look at converting small numbers that are already in standard form into a normal number. Okay, so we're going to look at converting small numbers that are already in standard form, and we're going to convert them from standard form into a normal number. So let's do an example. So let's look at a small number in standard form. So let's have a look at 2.1 times 10 to the minus 3. Now we know that's a small number because this is negative. And if we want to write, if we know that's a small number, then we know this be 0 point something, 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 something. Okay? And therefore, we're going to move the decimal point from here to the left. And how many times do we move it to the left? Well, we move it to the left 3 times. Okay? So, we need some noughts in there so that we can move it from its current position, which is there, and we need to move it 3 times. I've probably put too many noughts in there, but it doesn't matter. Let's see what we get. So we move it from here, and we go 1, 2, 3. So the new place for the decimal point is here. So just to be absolutely sure, we've got 2 decimal points there at the moment, which isn't a good idea. We certainly don't want a number with 2 decimal points because it's ambiguous. So instead, we write 0 point. And then what have we got? 2 noughts, 2, 1. 0.0021. Just go through that again. The decimal point would be here. We move it 1, 2, 3 times. So the answer is 0.0021. Let's do another example. Let's write 9.63 times 10 to the minus 5. That's a small number because this is a minus, and we want to make that into a normal small number. To make it into a small number, we know we must move the decimal point to the left. So we're going to need some zeros in there to help us. 963. Now the decimal point at the moment is here, but we need to move it 5 times. Here we go. 1, 2, 3, 4, 5. So its new position is here. And we don't usually put 0.000. We only put 0.0000963. So make sure your answer has only got 1 decimal point. That's very important. Make sure that you know that if this is a small number, this should be a small number. And make sure you move the decimal point in the right direction. One more example of this. Let's do 3 times 10 to the minus 6. Well, we look at this, we know it's a small number because of this minus. Therefore we want to make this into a small number. It hasn't got a decimal point at the moment, but 3 is the same as 3.0. So really there's a hidden decimal point just there. Okay? So we know we're going to need some noughts to account for the space. We'll put some in there, approximately the right number, and we know that we need to move, I'm sorry I've missed the 3 off the end, there's a 3 there. We know we need to move the decimal point from here, where it is at the moment. So in other words, it's there at the moment, isn't it? Just after the 3. Move it 6 places to the left. 1, 2, 3, 4, 5, 6. So a decimal point's going to go here. There it is. And let's just make that read better. 0 point. And then we've got 1, 2, 3, 4, 5 noughts. 1, 2, 3, 4, 5 noughts, 3. Okay, we're now going to look at multiplying numbers that are in standard form. So we're looking at multiplying together 2 numbers Both of them are in standard form. So let's start off by doing an example. So let's have 2 times 10 to the 2, and we want to multiply that with another standard form number, 3 times 10 to the 3. Okay? And it's pure coincidence that that's a 2, and that's a 2, and that's a 3, that's a 3. These are just simply two standard form numbers. There's one there, there's another one there, and we're multiplying them together. Now, when you multiply standard form numbers together, you multiply these numbers. So let's do that first. So that's equal to that 2 times that 3, and then times a 10 to the 2 times a 10 to the 3. In other words, what we're doing is when we're multiplying standard numbers together, we can rearrange the order of the multiplications, because the order of the multiplications don't matter when you're multiplying, do they? So we're writing that one, 2 times the 3, and then we're writing the index numbers. These are the index numbers. They're writing those together. So now we can just say 2 times 3 is 6 times, and now 10 to the 2, 10 squared times 10 cubed. Remember the laws of indices. When the base is the same, like that, you add the indices when you're multiplying them together. So 10 to the 2 times 10 to the 3 is 10 to the 2 plus 3. And 2 plus 3 is 5. So this is 6 times 10 to the 5. In other words, 2 times 3 is 6. And then add the indices. 2 plus 3 is 5. Let's do another example of that. Let's change the colour, and we'll do it in purple. So, let's have a look at this one. We're left with 4 times 10 squared times 6 times 10 to the 4. Okay. We say to ourselves, okay, I'm multiplying index numbers, which means I reorder them first of all. 4 times 6 times 10 to the 2 times 10 to the 4. Right? So you write these numbers first, and then write the index numbers. Now multiply these numbers together, and 4 times 6 is 24. 4 sixes are 24, so we write 24, and now we do the index numbers, and remember you add the indices. When you multiply the same base together, you add the indices. So this is times 10 to the 4 add 2, which is 6. So in other words, we add those indices to make that 6. And then I say to myself, and I must always do this, is this a number in standard form? And the answer is not quite. It isn't, because the number before the decimal place must be between 1 and 9. And at the moment it isn't, it's 24. So we must write that as 2.4. In other words, we've moved the decimal place from here to here. If we've moved the decimal place by 1 place, we must change this by 1. And so therefore it goes to 7. So just to recap, multiplying numbers that are in standard form is quite straightforward. Multiply the small numbers and then have a times 10 to the power and then add the indices of the times 10 to the powers. Make sure your final answer is in standard form. This one isn't, so we must do a little bit of extra work to convert it to standard form. Also note, when you're going from this to here, from 2.4 times 10 to the 6, How do you know whether this number must increase by 1 or decrease by 1? Remember, we moved this decimal place 1 place, so this must change. Well, you can think of it like this, is that 24 has become 2.4, so you've divided that by 10. So in other words, this number has become smaller. To go from there to there, this number has become smaller. And therefore, to compensate for that, because these are supposed to be equal, remember, these two numbers, then this must get bigger. So this comes smaller, that must go bigger. So that goes from 24 to 2.4, which is smaller. This must go from 6 to 7, which is bigger. Let's do one more example, and this time we're going to have a mixed positive and negative indices. In other words, we're going to have one standard form number which is representing a big or large number, and we're going to multiply that by a number in standard form representing a small number. Okay, so here we go. Let's do 6 times 10 to the 4. That's a big number, and we're going to multiply that by a really small number. So let's say this is what should we have? 4 times 10 to the minus 2. So you agree this is a big number, and we're multiplying it by a small number. Now when you're multiplying numbers in standard form, it doesn't matter whether you've got a mix of big numbers and small numbers, or if they're both big numbers, like in this case, or perhaps they could be both small numbers. The rules are the same. So let's follow the rules. Remember, we write these numbers first of all in the order, and then write the indices. That's the first step, remember. All we're doing is changing the order, which we're allowed to do. Now 6 times 4 is 28. 24 even. That's 24. 6 4s are 24. And now let's be careful here. We need to add these together. Well, 4 add take away 2. Let's write that out. So it's times 10 to the 4 add take away 2. Well, 4 add take away 2 is the same as 4 take away 2. And 4 take away 2 is 2. Okay, so instead of the numbers going up, they come down this time. But all we're doing is following the laws of indices. Add the indices together. 4 add minus 2 is the same as 4 take away 2, which is 2. And then we must always say to ourselves, is this final answer in standard form? It isn't, because this number here is 24, and it's not between 1 and 9. So we must make it between 1 and 9. So this is 2.4 times 10 to the... now what is it? Well, we've moved the decimal place from here to here, so we must change this by 1. This has been reduced, in other words, this has got smaller, so this must get bigger to compensate. So that must be a 3. Okay, we've just done multiplying numbers in standard form, and now we're going to do dividing numbers in standard form. And it's a very similar process to multiplying numbers in standard form. And let's do an example. So let's look at 6 times 10 to the 3, and we're going to divide that by 2 times 10 to the 2. And it's the same process again. First of all, you rearrange it. You recognise it's dividing, and you rearrange it so that these numbers go first. But this time we must remember to divide the numbers and not multiply them. And then we're left with times 10 to the 3 divided by 10 to the 2. So 6 divided by 2 is 3. And now remember, when you're dividing numbers, the laws of indices says that you subtract the indices. So it's 3 minus 2. So this is 3 times 10 to the 1. And that's your number in standard form. And 3 times 10 to the 1 is the same as 3 times 10, or 30 as a normal number. But that's a number in standard form. 3 times 10 to the 1. Let's do another example of that. Okay, let's do the example over on the right-hand side here. So let's look at 4 times 10 to the 4 divided by 8 times 10 to the 3. Let's do 2 this time, times 10 to the 2. Okay, so we're dividing, so we must divide the first numbers and then subtract the indices. 4 minus 2 is 2. So in other words, we take that number and that number, we do 4 divided by 8, and then multiply by 10 to the 4, take away 2, because the dividing means we take these away. Now, 4 divided by 8 is the same as a half, which is 0.5 times 10 to the 2. In other words, all I've done is said 4 divided by 8 is the same as a half, isn't it? And half is 0.5 times 10 to the 2. Remember, we must ask ourselves, is this a number in standard form? No, it isn't, because the number before the decimal place is not between 1 and 9, it's 0. So we must move the decimal place that way. So this is 5.0, or 5, we don't need the 0.0, times 10 to the... Now what do we do? Well, this has increased. To go from a half to 5 has increased, and therefore we must decrease this one to compensate. So that's to the power 1. Let's do one more example. So let's do 6.3 times 10 to the 4 divided by 6.3 times 10 to the 6. Same rules apply. We do the first numbers, and they're both 6.3, and we do times 10, and then we subtract the indices. 4 minus 6. Remember, 4 minus 6 is minus 2. And we say 6.3 divided by 6.3 is just 1. 6.3 over 6.3 is 1. So this is 1 times 10 to the minus 2. And that, of course, is a small number, but it is in standard form. The last thing that we're going to look at is adding and subtracting numbers in standard form. So, as an example, we're going to look at things like this. 2 times 10 to the 2, add 3 times 10 to the 3. Now there's a little bit of a problem here. Adding and subtracting numbers in standard form is not as easy as multiplying and divide them. What we cannot do, I shall repeat, cannot, I shall put it in red, cannot do 2 plus 3 times 10 and then add the powers. That does not work. And it's very similar to being able to say, well, this is a different type of animal to this. Remember when we were doing, for example, adding letters together? So if we had 2a, which is like 2 times a, and add 3 times b, 2 times a plus 3 times b, we can't really do much with that other than say it's 2a plus 3b. We can't combine the a's and the b's together in any sort of way because they're separate things. We could think of a's as being apples and think of b's as being bananas. If you've got a collection, all you can say is there's 2 apples and 3 bananas. You can't sort of say there's some sort of ice cream sort of made out of apples and bananas all merged into one thing. It doesn't work like that. So instead, what we've got to think of is how we can convert one of these standard form numbers so that they've got the same power. So what do I mean by that? Why does that help? Why does it help having the same power? So let's just write here at the moment that, let's write down there that the powers must be the same. Well, why would that help? Well, let's just have a quick look at an example. Before we go back to this example, let's have a look at a quick example whereby we've got the powers to be the same. So let's say if we've got 2 times 10 to the 2 plus 3 times 10 to the 2. If we had that situation, then these are very similar to adding 2 lots of apples. Oops, sorry, that 2 should be there. This is very similar to having 2 apples, and these are also apples because they're both 10 to the 2. And we've got 2 apples and plus 3 apples, that makes 5 apples. So you can see that that's quite possible to say that this is 2 plus 3, which is 5, and the times 10 to the 2 doesn't change because apples doesn't change. When you're adding 2 apples plus 3 apples, it still makes apples. So in other words, if we make the power the same, we can add them. So let's go back to our initial problem here and think to ourselves, how can we make the powers, these, the same? So I'm going to rewrite the question out, 2 times 10 to the 2 plus 3 times 10 to the 3, and see if we can convert the powers to be the same. So back to our initial problem, which is 2 times 10 to the 2 plus 3 times 10 to the 3. So the thought process is I'm adding standard form numbers. To do that, the powers must be the same. Are they the same? No, they're not. Therefore, I must convert one of them so that it's got the same power as the other number. So let's try and convert this one, this number here, so that it's got to the power 3 instead. In other words, what we want is something that looks like this. So this number hasn't changed, that's still the same. Yeah, these are exactly the same. But this, I've got to figure out what goes inside here to make this at times 10 to the 3. Well, what have I done to this number to make it that number? I have increased the power by 1. Okay? And so to compensate, I must reduce this number by moving the decimal place by 1. And how do I make the number reduced? I move the decimal place to the left. So this would be 0.2 times 10 to the 3. So can you see that I've increased this number to compensate, because these two numbers must be the same, or we want them to be the same in order to not change things. I've multiplied that number by 10, in other words I've increased that power by 1, and therefore I must move this decimal place by 1, and I'll need to make this number has got bigger, so this number must become smaller. Now, the point of doing that, of course, remember, is to make these powers the same. And they are now, they're both 3. So I can simply add these animals together. So this is equal to 0.2 add 3 is 3.2, and then times 10 to the 3. So I just need to check, is that in standard form? This last number, yes it is. This number to the left of the decimal place is between 1 and 9, so we're in standard form. Okay, let's do another example. Change the colour here. Oops, sorry, move this up. Sorry about that blue line, ignore that blue line. So let's do another example. We're going to add together 3.3 times 10 to the 7, and we're going to add to that 7.2 times 10 to the 6. Okay, so here's the thought process. I'm adding standard form numbers, adding scientific numbers. To add scientific numbers, these powers must be the same, but they're not. So I need to convert one of the numbers, either this one or this one, so that these powers are the same. So let's try and do that. Well, let's try and convert the first one. So the second one stays exactly the same. So this one, I need it to be 10 to the 6. The question is, what goes inside here? Well, I have changed that by 1. I've reduced that by 1. And therefore, if I've reduced that by 1, I must increase this by moving the decimal place by 1. And I increase it by moving the decimal place to the right. So this becomes 33. I can just go through that again. I change this to the power 6. I'm not allowed to do that without compensating. So I've reduced this, making it a smaller number, and therefore I must make this a bigger number to compensate. So now, because we've got the same powers, we can simply add these numbers together. So this is 33 plus 7.2 times 10, and then the powers remain the same. It's times 10 to the 6. And 33 plus 7.2 is 40.2 times 10 to the 6. And I say to myself, is that a number in standard form? No, it's not. I must move that to the left. So that's 4.02 times 10 to the 7. So remember, how do I know it's times 10 to the 7? Well, I have reduced this number to go from 40 to 4, and therefore I must increase this number to compensate. So another example, 4.1 times 10 to the minus 2 minus 0.6. Let's make it a standard form. Let's do 6.6 times 10 to the minus 3. So here's the thought process. I am subtracting or adding standard form numbers. I'm subtracting in this case. The powers must be the same. They're not. This one's minus 2, this one's minus 3. So they're both small numbers, but they don't have the same power. So I need to convert one of them to have the same power. So let's convert the first one to have the same power. So to make it the same power, I must make that a minus 3. Let's leave the second one exactly the same as it already is. Now we've got the same powers. Now what did I do to go from minus 2 to minus 3? I made it smaller. I made minus 2 is smaller to go to minus 3. Okay? Yeah, imagine that's on the number line. Here's a number line. Oh, here's my number line. 0 there, minus 1, minus 2, minus 3. It's going from here to there. So the number's going to the left. It's getting more negative. And therefore, because this has gone smaller, if you like, this must get bigger to compensate. And we've got bigger by 1, so we move the decimal place by 1. And that goes by 1, so it goes to 41. Now the numbers, the powers are the same. And now we can subtract the numbers, so it's 41 minus 6.6 times 10 to the minus 3. And 41 minus 6.6 is 34.4. But that's not in standard form, so I need to write it 3.44 times 10 to the right. Now, times 10 to the what? Well, to go from here to here, I've reduced the number. So I must increase this one to compensate. And if I increase minus 3, I've moved this once, decimal place once, so I need to increase this by 1. And how do I increase minus 3 by 1? Well, it becomes minus 2, because minus 3 plus 1 is minus 2. You need to email me this magic word to tell me that you've watched the video